Next, let's talk about innovative education or training. Learning is a two-way street. There are different ways to train students. In extreme cases, we have the intelligent trainer, that is the teacher, and the smart trainee, the student, a subject we shall elaborate later. Briefly, innovative education consists of three types of learning, as given in slide 36. The art of innovative learning. We have the art of remembering, that is associative learning, the art of understanding, cognitive learning, the art of learning with thinking, and I call that creative learning. If the subject to be taught has to be memorized, the teacher can teach the students to use smart, associated memory. If the subject to be taught is more dependent on understanding the basic concepts and physical significance, then the simple, relevant cognitive illustrations should be used. For example, the subjects such as historical events, geographical locations, and languages have to be memorized. The teacher can teach the students to use smart associative memory. However, subjects such as physics, mathematics, and engineering are more dependent on understanding the basic concepts and physical significance, then relevant cognitive illustrations should be used. This slide defines what I mean by creative learning. The meaning of creative learning does not mean only one has to understand how to learn, but also why one is learning. Creative and intelligent methods have to be developed with thinking to benefit the learner. For example, one not only have to learn the methods of solving a set of differential equations, but one should also know the constraints, the limitations, as well as why we're doing it. Strictly speaking, the associative and cognitive learning are not mutually exclusive. Subjects such as literature and history also require students to understand the significance of the events, as well as remember the dates and the names cited in historical periods. Notice that subjects such as mathematics, physics, and science require memorization as well as understanding. It is a matter of a degree which subject is more relevant for memorization and which subject is more suitable for students to understand the basic principles. I would like to stress again the essence of creative learning. In this information age, most of the people, including some engineers and scientists, know how the digital system operates, yet some of them may not know why we developed it. Let us look at the major differences between digital and analog system as shown in slide 39. On the left-hand side, we see that the digital form, for example, you have 0 and 1. On the right-hand side, the analog system, it has multiple levels. Digital system has lower information content, 1 bit per level. The analog system has high information content, higher bits per level, and there are other characteristics as well. Looking at this slide, one may ask, since the information nature of a digital system is lower than analog system, why does one go through the trouble to transform the analog to digital and then to transform it back to analog for the receiver? The major reason is by taking advantage of the high-speed transmission of electronic and the electromagnetic waves for digital transmission. The speed of electromagnetic wave is at the velocity of light. It can carry and transmit a lot of information at that speed. As I always told my students, one cannot get something from nothing. There's always a price to pay. And the apparent price paid must be the high speed of electronic and electromagnetic transmission. To clarify my argument, let me provide a simple example in the next slide. When we wish to transmit 26 English alphabet in digital form from A to Z, this is equivalent to a 26 distinguishable levels of amplitude. The corresponding coded digital forms are given by a total of 26 binary coded format. We know that the information content of each alphabet can be shown to equal to the log, shown to be 4.7 bits. It requires 5-digit representation, that is 5 bits per alphabet, where we assume the selection of each alphabet is equal probable. Since each unit digit represents 1 bit of information, the question is why we use a lower information content signal to transmit a higher information content signal. The apparent reason is the noise immunity in the transmission process. Otherwise, why would one pay for a longer data rate transmission? In our case, it is the 5-digit coded signal per alphabet. For example, under no noise condition, one can simply transmit any alphabet without digital conversion as he or she wishes. Because no noise interference, one can receive the same alphabet precisely, and it also does not need to decode the digital form back to alphabet. And each letter, that is the 5-digit coded form, needs 5 bits of information per letter as transmitted by binary form. This example is similar to traveling by car from one place to another. To save time, he or she opted to go on the express highway rather than driving on a slower and shorter street under the assumption that there is no traffic jam. This is precisely the reason we paid for a slower transmission per alphabet by digital form. As we see that the electromagnetic wave travel at the speed of light, a very small fraction of delay is negligible and it is insignificant. Nevertheless, the above illustration shows the essence of what I mean by creative learning. It is not just learning how a digital system operates. It's also learning why the system is actually working.